We'll start out with a simple example of an exponent. An exponent is used to show that a number is multiplied by itself a certain number of times. For instance, we could have a number 2 to the third power. Our base is 2 and our exponent is 3. And what this means is we're saying 2 times 2 times 2. And that number is equal to 8. So where our base is 2, our exponent is 3, the exponent is telling us how many times to multiply our base times itself. Now exponents can also be negative. If I said, for instance, 3 to the minus 3, we could have that where our exponent is a negative 3 and our base is the number 3. And a negative exponent indicates that the reciprocal of its number should be multiplied by itself. In other words, the reciprocal of 3 is 1/3. 1/3 times 1/3 times 1/3, and our answer would be 1 to the 27th, where 3 times 3 times 3 is 27 on our denominator. We can also do calculations involving exponents, and we can do addition, subtraction, multiplication, or division. To multiply two numbers with an exponent where the numbers have the same base, we add those exponents. To divide two numbers with the exponents having the same base, we subtract those exponents. Let me give you an example. If we had, for instance, 2 to the fourth power times 2 to the second power, where our base was the same, then we could say 2 to the 4 plus 2 power is equal to the sixth power. And then we could easily calculate this as we did up above. And in the case of division, 2 to the fourth power divided by 2 to the second power would be 2 to the 4 minus 2, or 2 to the second power. And again, we could easily calculate that as we did up above. Now, when we're talking about adding and subtracting with different bases, it's a little bit different. For instance, if we had 2 to the fourth, multiplying and dividing, 2 to the fourth times 3 to the second, we would have 2 to the fourth calculates to 16, 3 to the second is 9, and 16 times 9 would be 144. And just if we were dividing 2 to the fourth divided by 3 to the second, we'd have 16 divided by 9, and that would be equal to 1.78. And any number that has a zero exponent is equal to 1 by definition. Now, some numbers can also have base exponents that are where the base is equal to 10. And this is quite common in this industry, and I'll give you an example of that. 10 to the second power is equal to 10 times 10, which is equal to 100. And we notice that the second power tells us we have an answer ending in 2 zeros. So we would have 10 times 10 is equal to 100. This exponent simply tells us how many zeros we have. 10 to the third power would be 10 times 10 times 10, or 1,000. Again, the exponent being number 3, we end up with 3 zeros. Similarly, with exponents involving negative exponents, 10 to the minus 2 is the reciprocal, 1/10 times 1/10, or 1/100th, and we can rewrite that in a decimal form as 1/100th, as you see here. So the exponents basically tell us whether or not it's a positive or negative exponent, and tells us basically if it's going to be a number greater than 1, if it's a positive exponent. If it's a negative exponent, it's going to be a number between 0 and 1, greater than 0.